As mentioned in the previous exercise, there are many methods that you can use to identify the hits from any of the RNAi library screening. That include, for example, using the Z-score or using the RSA analysis or using the rigor analysis. In this exercise, we are going to show you how you can actually use the RSA analysis to actually identify the hits from the RNAi library screen. Now, before we go into the RSA analysis, you should have all the Z-score calculated based on the shRNA-seq, and we will use this Z-score as an input for the RSA analysis. Now, before we move forward, what I'm going to do is, okay, I'm going to create a new input file in Excel. Basically, you just create a new sheet, and then you are going to label 3 columns with the header gene ID, well ID, and also for the score. Okay, so now we switch back to our Z-score Excel sheet here, basically. So the gene ID is basically a gene symbol that we have. We can actually copy this over here, the gene ID. And then the well ID would be the TRC number. So, or the reference, or the reference here. Then we will copy this again, and then we will paste it and the well ID. And then after that, you will then copy the score, in this case here, which is basically the Z-score here. We're going to scroll it down and then copy the Z-score all the way from the bottom. So, okay. Now, you will see that, okay, some of the Z-score have actually a blank value. For RSA to work, you will need to remove those blank cell. Basically, I'm going to select the blank cell, and then I'm going to delete all these rows. Okay. Okay, so now you should have all the data ready. The next thing I'm going to do is I'm going to save this, okay, as an input file, but in the CSV format. Okay, so research. This will be under Drive. Okay, and I'm going to save this under input. Okay, dot CSV. Okay. Next, what I'm going to do is basically launch the RSA program. Now, the RSA by itself, by default, it is already set in a way to actually identify the genes that when knocked down can actually induce tumor cell death. So in that way, basically, it is set to identify the genes that are depleted, or the shRNA that is depleted in any of the shRNA library screen. So in our case, we actually don't have to change anything. You can actually use back the same setting as it is. If you want to understand more about what is this lower boundary and the upper boundary setting, you can actually read on the help file to understand more about the algorithm. So anyway, so for this exercise, so what we are going to do is we are going to input the file that we have created just now. So this is in the CSV format, and then the output file, okay, would basically save on in the same folder as well. Before you press the run button, is always remember that you actually have to close the input file first, or else then it will come out with an error message. So now that input CSV file is already closed, so you just need to press the run button here. Okay, then once you finish, then a pop-up window will come up here. Now, okay, so now if we go into the output file, so we can actually see what are the data that is being calculated. So basically, when you open the output file, what you can see is that the gene ID is what we input, and then the well ID is also what we input. The score, this is actually the Z-score that we input as well. Now, the most important thing that column that we want to pay attention to is actually this one here, which is the log p value. As you can see here in this data set, basically, well, for CCAP5, there are about 20 shRNA that target the same gene, and when you consolidate and take into account all the different shRNA, so the probability or the p-value, okay, for CCAP5 is appear to be very, very significant, which is basically at the log p of minus 13. So if you want to know the p-value, you can easily calculate it. It's basically 10 power of the value. So it is actually 6.92 6.92 times 10 power of minus 14, the p-value, so it's highly significant. So now there are also other other results that you might be interested. For example, number of hit well. So there are about 17 hit well out of 20. So again, while you can read up more about the activity or the information on RSA, then you will comprehend much about all these additional data as well. But for this exercise, what we are going to do is we are going to focus exclusively or more into the log p value. So you will see that, okay, for each particular gene, there's only log p value. So this is common because, as I mentioned it before, the log p value basically reflect the p value of the particular gene when they consolidate and take into account of all the SHR. Okay, the next thing I'm going to do is I'm going to put it into the master sheet that we have created since the beginning of this exercise. Basically, in here I have one column which is basically all the genes in the data set, so altogether 3,400 of them, and across I have all the cell lines that's included in the study. So what I'm going to do is I'm just going to copy the gene ID and also the log p value into this data sheet here. Now, and the next thing what I'm going to do is I'm going to remove the duplicate, okay, so that each gene will then have, okay, one unique log p value. So the next thing to compile it into this table, basically I'm just going to use VLOOKUP, okay. So the lookup value would be this, and then the table array would be here, and then return of the column number 2 here, and then false. So remember the VLOOKUP formula again. You can look at the previous video how it is being created. It is a very useful formula in Excel that you can use it to match the genes basically, or in the data set. What you need to do is then you just copy and paste here. Just to double check, basically the CCAP5 is minus 13, so I'm going to search for CCAP5, see whether, okay, I can find it. Okay, I think that's fine. So it will take a while for it to compile. Okay, we can find CCAP5, for example. Okay, you can see that it's minus 13. So, and the CORO2B is minus 0.06. See whether we can find, see, minus 0.066. Okay, so that's all for the RSA. Basically, you just need to do for the rest of the cell lines, and then you can then get the p-value for each of the genes, whether they are significant or not. Thank you.